Alrighty. Hi, everyone. My name is Winston Wong. I look after the partner and alliances for Australia and New Zealand at HashiCorp, and I'll be your host today. I'd like to start by thanking you all for joining us for our webinar, Identity, the Key to Zero Trust Security, which will be presented by my partner in crime, David Wright from HashiCorp and Jay Doyle from Microsoft. Predicated on securing everything based on trusted identities, Zero Trust Security enables organizations to move beyond traditional perimeter-based security approaches to tackle the challenges of today's dynamic multi-cloud infrastructures. HashiCorp and Microsoft Azure ensure that each access request across clouds, on-prem, and low-trust networks is authenticated, encrypted, authorized with the least amount of privilege. So today, Dave and Jay are going to discuss the value of integrating Bolt with Azure, creating dynamic access based on different policies. Before I pass over to you, Jay, I'd just like to go over a couple of housekeeping items. So first of all, I'd like to note that this session is being recorded and the recording will be shared with everyone within the day or two. We'll ensure that it's emailed out to all of you. Secondly, please submit any questions throughout the session by the Q&A tab. I will host the session towards the end to answer these questions, but also Dave and Jay will be monitoring the questions, the Q&A during the session as well. So with that, let's go ahead and get started. Over to you, Jay.
Thanks very much, Winston. So thanks, welcome everyone, and thank you for joining today. Great to be here to talk about Zero Trust Security. So let's get control here. Perfect. So although it's not new, there is a lot of attention at the moment around zero trust, and it's become more relevant today than it may have been in the past. So the reason for that is we've seen that attacks have become much more sophisticated and widespread generally. This has been exacerbated by remote work and hybrid work, BYOD, and accelerated by COVID. So why are we having a zero trust conversation? So Zero Trust focuses on the original missions of cybersecurity, which is about keeping assets out of the control of attackers, but brings a fresh perspective and approach. The IT environments we run have been complex since the early days. There's many devices, identities, interactions between them, and so on. Previously, we trusted the networks, which were protected by a security perimeter. But as the attack started to emerge on our IT systems, as I go too far in the slides, the first thing we tried into IT security was to create that concept of a security perimeter. This worked for a while. It seemed to be a good, simple solution because most productivity at the time was done in the office, inside of a corporate network. It was done on desktop servers, mainframes, terminals, and so on. But over time, that approach didn't hold up. The world of productivity changed and grew with mobile devices, Wi-Fi, cloud services, remote productivity, and so on and so on. At the same time, security threats expanded into a full spectrum of attacker motivations. You've got criminal associations, you've got nation state attacks, hacktivism, and all these different types. This continually adds new creative attack techniques to get around that network perimeter. So these two factors eroded the underlying assumptions that everything to be protected was inside the corporate network. The network security perimeter tactic fell away and it didn't meet the needs of the organizations anymore. So, with that, security needed a comprehensive security strategy to prioritize how to deal with these new complexities, which is the strategy that we are now calling Zero Trust. So we can go through it a bit and have a look at the comparison. So a traditional approach to security with the siloed security practices, as we said, doesn't really work so well anymore. It's not enough. We used to have it where users were employees, but that's all that we were looking at. But now we've got employees, we've got partners in the directory, customers, external identities, bots. We've got BYOD, bring your own devices, IoT, whereas we used to be just dealing with corporate managed devices. Applications are becoming segmented. We have cloud-based applications, SaaS, a whole range of different applications, as well as APIs that we need to protect. Previously, work was done at work, right? You would be in the office, but now it's done from anywhere. We're enabling that flexible work environment and hybrid work scenarios for different people. And traditionally, there was a few types of attacks that would be attacking different organizations. But now there's new multi-vector attacks and cloud-based attacks, which we have to deal with as well. So the old assumptions don't work so well in the new world. We don't have everything sitting behind a corporate file anymore, keeping everything safe. So the strategy we have of zero trust is led by these three guiding principles: verify explicitly, use least privilege access, and assume breach. Verifying explicitly means we don't know what we don't know. We need to authorize and authenticate at every stage we can, and take in telemetry and signals from devices, identity, location, device health, resources, and different telemetry points to make decisions on how we authenticate and authorize people. We need to limit access with strategies like just-in-time, just enough access, risk-based policies, and so on. Ensure that we have no standing access and administrative controls. And assume breach to limit the blast radius. Use micro-segmentation strategies, end-to-end encryption, continuous monitoring, and so on and so on. And so this brings us into what we see as what we call as building the foundation of zero trust. So zero trust has 6 different pillars that it's built on, but the foundations are focused on identities and endpoints. And the reason for that is because that's where we can have the greatest impact. It's where we can minimize the risk by focusing on the areas where the majority of the attacks are happening. As you can see, 80% of breaches involve the use of lost or stolen passwords. By prioritizing the protection of identities and devices as the foundation of a zero trust strategy, this supports the goals of providing security and secure, productive collaboration from anywhere. So as we expand that out from zero trust, focusing on identities and endpoints, we've also got to consider that we're living in a multi-cloud and hybrid environment. We can expand it out again, and multi-cloud environments are inherently complex, right? So one identity can access thousands of permissions across multiple clouds and authentication systems. Whilst these are not limited just to user identities, but we've also got to consider workload identities, applications, and other services, which can also have access to the same high-risk permissions across the environment. Multi-cloud adoption itself has led to an explosion of identities access and permissions, creating new access control challenges for organizations. This has also been driven by the explosion of workload identities, such as virtual machines, web apps, containers, scripts, and the number of identities accessing cloud infrastructure has increased by 50%. We've also seen an explosion of permissions amounting to over 40,000 across key cloud platforms, of which more than half are considered as high risk. Adding to this, according to some research which we have done, we found that more than 90% of identities are using less than 5% of the permissions granted to perform their daily functions. As the number of identities and permissions continues to grow, so does the risk that they pose to the organizations and infrastructure. The biggest problem is that the identity and security teams don't have enough granular visibility into the identities, permissions, and resources across the infrastructure. Given that each cloud infrastructure follows its own access control operating model, it's become difficult and time-consuming for admins to implement consistent security policies across the cloud platforms. And ultimately, these trends have increased the risk of accidental or malicious permissions misuse. So with the added complexity of hybrid and multi-clouds, and this brings us back to the critical importance of securing identities and devices as a priority, aligning to the zero trust strategy, which allows us to measure security controls and systems against those 3 guiding principles of zero trust. And with that, I'll hand over to you, Dave.
Thanks, Joe. So I think the important part here that we want to try and, or the principles that are coming across, is that HashiCorp fits into that as being able to provide a tool set that allows you to hit those first guiding principles as Jay outlined. So we're looking at trusting nothing, we're looking at enforcing authentication, and we're looking at providing authorization as to what they can do. So who are you, what are you doing, and what are you allowed to do? And then use those principles that Jay talked about to define that what you can do to be the minimum allowable amount to actually do that. Now, across obviously infrastructure, there is a lot of different elements that you need to interact with. So there could be machine to machine, there could be human elements into that, and there are different inter-platform. As you know, as Jay pointed out, we're in a multi-cloud world, and that multi-cloud scenario means there are a lot of different elements that need to be controlled. So that's access keys, certificates. All of these elements need to be controlled and provide an infrastructure or tooling set that allows for easy control of that. Because ease is going to be a key point in getting adoption. If it's easy to use, if it's easy to integrate, then people will adopt it. Once you have adoption, so you have that larger element of the community or your work environment actually uptaking and standing by your security standards. And you know, one of the challenges with security is obviously getting people to adopt and use those standards. And so where HashiCorp fits into this is we were fundamentally built around the challenge of solving how can we help customers move to the cloud. We created our cloud operating model, which is kind of segmented it into 4 key areas that we know that are defined challenges that any user will face in their maturity curve as they go towards using and adopting cloud services. So that's the first part is around their infrastructure. So how are they actually going to automate? How are you going to provide automation standards? And we have Terraform as a well-known tool within that area that the customers can use to adopt and drive infrastructure changes. We then have our security pillar, where again we have Vault, which is going to be a lot of the focus of what we're going to be talking about today. And that's a Gartner Magic Quadrant leader in the secrets management space. And we'll look at some of those scenarios around how that tooling helps meet some of those guiding principles that Jay was outlining. And then we have a new open source project which we've recently launched, which is Boundary, and that covers off again one of those segments that we were looking at to provide. And then Consul, which kind of addresses the other one. Now Consul is in our networking space and was fundamentally thought of as that connectivity play, but obviously as we are starting to see more and more organizations look into how do we provide and deliver that end-to-end zero trust principles, we're seeing more and more customers looking at clever ways to use that connectivity piece as part of that overall guiding principle. And so all of those products are available from us as binaries. They're also available as commercial offerings. And those commercial offerings can be acquired through Azure's marketplace. And the reason that I mention this is that leveraging that speed and adaptability of moving into using cloud, one of the hard parts of actually being able to do that at speed, particularly as you start to innovate, start to experiment with tools, look at how you can actually get your tool sets into your developer environment, is obviously having to go through the traditional procurement cycle. That traditional procurement cycle, easy for some to say, obviously can slow down a lot of that velocity that you just want to try, get there, use it, see if it actually provides the value that you think it does, and then control that cost. And Azure's marketplace actually allows you to do just that. Because the software is added into your existing subscription, you can keep control of it using the cost management tool. You can associate it with any of the agreements that you've got around your Azure consumption. It's a single line item on your overall bill, so it actually is on your Azure bill as an individual billed item. This means that procurement both can see who did it, track it, and see what that actual cost consumption is, and start to associate that with a line of business. And this becomes really important as more and more people start to adapt and adopt tools, so that the procurement and financial teams can actually see and track who is doing what, but make sure that software is actually being used, or try and consolidate that spend to see how can we really take advantage of that buying power that we've now created around that. And all of our tools are available in there. And so if you want to do a purchase through the Azure Marketplace, work with your Microsoft account team or one of our HashiCorp team, and we can set up a private offer that will allow you to actually procure through the marketplace. So getting back into our zero trust element, let's take a look at that machine component. How do we understand what the machine's doing? Who are they, and what are we going to provide to them? And this is where Vault really comes into play. So Vault is fundamentally defined around three key areas. So that's defining a client, authenticating and understanding who that client is, and then providing access to a resource via its secrets engines. Now, in between that, we define policies, but fundamentally the workflow is we do not trust anything. So immediately to Jay's point around creating that definition of who you are and knowing who or what you are. And a client for us can be a machine, can be an application, can be an individual. And so we force that element to be authenticated. We authenticate that against a known trusted source. So we're not the trusted source of providing identity. That is done by one of our authentication providers, LDAP, for example. That then feeds back. We create a token. That token is then associated with the client. And this is the token that then actually tracks what that client is doing across particular different engines or access. And it also has a mechanism for us to then time it and then be able to time out that client. So if the client obviously has a minimum amount of time, we can set, or admins can set a validity to that amount of time that client actually has access. Now that could be a one-time access. It could be for an application that has access for a sensible working period for it to actually use. But you're starting to put in those starting to put in the principles around making sure the client has minimum access and only a defined amount of time. So you're not having long-lived credentials hanging around, which then increase your risk of those potential attackers, as Jay outlined, finding them and actually compromising it. And if they do, it will rotate, and then they have to actually start all over again. And then once that client is authenticated, it has that mechanism to be able to talk to our secrets engine. We can enforce a policy around that, which allows us to then set what they can do and that authorization around what exactly the actions are. And of course, you would use that around a minimum policy, a minimum privilege approach. And so fundamentally, Vault is built around this identity brokerage component. And where this becomes really important is, as Jay pointed out, around that multi-platform, and I like to say multi-platform because it may be across clouds, maybe across on-premise, maybe across a private cloud component, but across that platform, you can start to broker and have a single point of control that now can talk and issue keys around that identity-based mechanism with a defined time period and defined privilege that allows for access from a user to or machine or application to any of those components across those platforms. And because it's centralized, it then adds the benefit of being able to be centrally logged. So now you have a single point of control to see what everybody is doing. You also have a single point of control that if you think something has been compromised, you can enforce that to then roll those changes. Now, whether that's certificate or identity or any mechanism, but you have a single point of control that means that wherever your access is going over from the different platforms, you have a single point that enforces that they have to re-authenticate. So if you feel something is compromised, you can take an easy action. And again, that ease of use of security being a guiding principle around being able to actually get it adopted and used. And so as we move into how do we then solve that machine-to-machine component, well, then we start to think about how Consul can solve that. Now, Consul was, as I said, was originally a service discovery and infrastructure automation tool. But what we're seeing is the use of the service mesh as part of the zero trust philosophy around establishing that end-to-end control. And so because Consul is fundamentally based around services and having a service talk to a service, you can define a policy which then says, you know, my web front end can only talk to my back end. And because that policy is defined using a mutual shared MTLS point-to-point connection. We can enforce that policy around that point-to-point communication, and those two endpoints can then only communicate around there. So again, establishing identity, so that machine has to obviously authenticate to be able to establish that tunnel, so we know who it is. We're putting policies in control of it to define what it can do, and then allowing it only to specifically talk to another specific endpoint service that it needs to talk to. And again, minimizing your risk around those applications. And so as we see more and more of these, or the need for more and more of this type of security. So what we're seeing Consul really adding value in terms of the service mesh component is when it needs to go across those multiple platforms. So in terms of being able to add value outside of some of the native service meshes, for example, is that Consul can run as a cluster in any platform or on-premise, and now you can actually have that same point-to-point automatically service discovery connectivity, regardless of what that is. So that could be across clusters, Kubernetes clusters, it could be across clouds, could be across multiple different or disparate platform types. And so then we move into that, how do we solve the human component, which is usually, to be fair, is probably the most difficult part. Machines, you can establish a process, machines, you can tell them what they have to do, and then they usually will do exactly what they're told. Whereas humans, on the other hand, will rarely do what they're told, like my children, and will really follow any of the things that you want them to do, and suddenly come up with these brilliant new ways of destroying stuff in our house and establishing a whole new way of working. And so to meet that challenge, what we did was launch Boundary. And this was a new open source project that we are supporting. And that open source project is focused around trying to change that traditional workflow that we see organizations using to access predominantly cloud resources. And so, you know, in the traditional workflow, you had to establish your VPN, you had to know how to get access, what keys, how to actually, in some cases, have certificates, on what certificates on the machine that was. We then had to connect to a specific network. You may have had the wrong permissions. So I know in my VPN admin days, I had set up where users were, you know, you applied that least access policy, but that actually meant that users needed to gain access to subnets that you weren't aware of. You had to have the right IP rules in base to allow them to gain access through the inter or security endpoints and across security domains. And then obviously through all of that, you then have still the problem of the secrets management and credentials around what credentials do they use, are they static, how does that integrate? And so what we've tried to do with Boundary is really change that workflow. And so onboard and log in with using a trusted identity that you have. So one of those, again, one of those authorized trusted identities that we spoke about. Create a configuration that has clear role-based access that then will automatically select which host that they're allowed to connect to based on those policies. And then with integration in with something like Vault, can actually create those dynamic credentials and allow them to connect to that resource automatically. And so that simplified approach is where Boundary is looking to go. Now, obviously, you know, it's only a few years old, so it's still in development, but we've had some great integrations. We recently, you know, announced an integration with Azure AD around that workflow principle where we have the users authenticating, we then have them getting an authorization mechanism and gaining access from leveraging something like Vault. And then the final piece of the puzzle is obviously outside of where our tooling fits, but does fit in with using as an SSO engine such as Active Directory. So again, looking at how you can leverage both the Microsoft Cloud to provide fundamental components that fit into those guiding principles, use some tooling from HashiCorp and stitch them together in a relatively easy manner, and we'll show that in the demo, where you can then use that tooling to provide the necessary components to get you on the road to providing overall zero trust. And whilst we've talked about zero trust here as a as a guiding principle and concept, the tooling that we provide is part of that overall concept around delivering it. And it's key to understand that, and I think Jay summed it up really well with saying it's the 80% of those breaches come from these basic core elements. So if we can solve those, we've solved 80% of your problem to start with. And if we can make it easy as well, so that developers and users integrate quickly, then you have an acceptance. And so you've solved the 80% rule, and you're getting high usage and people not trying to work around those systems. And so when you put all of these things together, obviously this is where that tooling comes together, working in conjunction with Microsoft to provide those basic necessary building blocks to get you into looking at how to do zero trust. And so with that, what I wanted to do was actually just show a few different things that hopefully people will find interesting. The first of those was I just wanted to show you our HashiCorp cloud platform. So the HashiCorp cloud platform, which is easier said than done, which is HCP for another 3-letter acronym out there that is going to make people's lives even more complicated, is our SaaS delivery mechanism. And so in here, we actually have our Vault cluster running. So this Vault cluster is up and running, and so in that it takes away all of the inconvenience of having to build this internally, but you can connect to it both through a private network or a public network and manage your Vault very similar to you would do normally. So anyone that has seen Vault in the past will recognize this GUI. Anyone that hasn't, this is our GUI front end. And so in this component, we can have this concept of creating our secrets engine. So we'll just simply create our secrets engine here. We'll create a path to it, for example, and we will enable that engine. So now that we have the actual engine enabled, let's create our secret. So we'll do, what should we do? Let's do test and web app. And then we need to create our a key value pair. So API key, and let's go with something. 1, 2, 3. All right, so we've created a very basic secret. And this obviously is very simple, right? It's a key value pair. This is available with Azure Key Vault, for example. But this is just the starting place where we can then move on to some of the more complex elements. So if we just flick through to actually thinking around how we can call that, I've got a simple script here that just calls it, and hopefully I put the right context in. No, I didn't. What have I done wrong? Let's have a look. I put wrong name. There we go. Let's just flick that back to change the path. Let's start again. Let's go to start again. Oh, secrets. Great secret. Let's do it. Just test slash. The demo gods were against us. Oh, and I've done that wrong as well. Look at that. Let's delete that one. So we destroy all versions of it. Create a new one. That's it. Take more time. Right, hopefully this is where we get this to call. So there we go. Right. So we've made a simple curl request. So Vault is API based. This pulls back that data. We just run it through a JQ editor, and we have our access to our key value pair as an API from anywhere. This was over the internet, for example. And so you can easily set that up. You can easily get access to key value pairs. Now, obviously, from a more complicated scenario, what we want to do is actually start to integrate that into our application use, right? So this is great. I get some basic kind of value from this, but how do I get this into my applications? And so what we can do is we can actually integrate this into a .NET project, for example. So here, this code is available, and I'll share this link with everybody. And there's a run list of commands that you can go through. So basically, what we're doing is we are actually integrating into Vault. It has a preset key that we've set around our project API and a role. So we will do get a username. So what we are now doing is authenticating, or effectively taking that machine role and authenticating dynamically to Vault to get a dynamic username, so our V token here, and password. So we need to actually define our or export those as environment variables so that we can get some local connectivity into this. So what we're going to do here is we will just take our username and create a variable. And what we're doing is we're simulating here what our application would need to do. Now, obviously, this would be done using a sync file or some secured mechanism. But just for showing you here, so you get some form of understanding about what we're going to see in a little bit, we're exporting it there, right? So what we then do is we can run a Docker call. So I have a Docker container running here. This will actually then call using those variables. And so now we're actually on a database. So we've used a dynamic set of credentials to gain access to a database that we can then actually read from. Oops, that's over. That's a bit laggy. My internet is a bit laggy. Kids must be, oh no, kids are at school. I don't know why that's it. So there we go. So now we've actually used a dynamic password that we asked for, generated it. We created a variables file, effectively, or a way of consuming those dynamic credentials. And now we've actually then used those to call our database. So we've now had dynamic time-specific credentials that will expire either based on time, number of usage. So you can say, right, if someone starts to try and hammer this database with credentials, we can actually time it out after X amount of time. Again, making it very difficult for brute force attacks, making it very difficult for those reconnaissance mechanisms where they're trying to find weak spots in your environment. And so if we now think about how we can look at what that file looks like. So initially we need to obviously have a way to authenticate. So our project was using a role ID based around our app role. So an app role is an internal Vault mechanism that actually allows for that privilege mechanism. So we can associate a policy around that, and it defines and gives us a specific secrets key that allows us to then authenticate, get that username and password to actually then mechanism. So this is our mechanism for finding out who we are. So that machine identity, and then this is the dynamic credentials that we get to actually gain access. So once we've been trusted, we can then actually ask for our credentials and pass on. So in terms of looking at that in a .NET project, for example, you can see here that within our secret agent, so this is our folder that we are going to take and dynamically create those credentials. We're looking for we're going to create this what's the word I'm looking for? File dynamically, right? So this file becomes our app settings that we will be using to roll into getting that .NET to user application. So if we look at our template file, so this is our template file, we can see that we can define in a PID ID. We define an address that we're going to run to obviously authenticate against. We're having a sync file, so this would normally be secured, but in this case we're not. So this should be an encrypted file, but we're exposing that so that we can see what's going on. And then we're authenticating using the file and that role that we identified. So we've got our role ID, we've got our secret ID, so we've kind of statically done that. But in this case, that could be defined or rolled into an application that is rolled out, or it could be part of a cubbyhole component that you actually need to get that first secret. So there's some interesting, conversations around how do you get the first secret to get the secrets and making it dynamic. And we have a solution with that using our cubbyhole technique. So if we then think about our commands, so we've gone to our template phase, we looked at our token. So let's just run our script as time is getting on. And oops. So what we should see now is here we have our app settings folder. So what we did was we actually went and asked for our credentials, and you can see that Vault got the credentials. It used the Vault agent. So the Vault agent is a process that instead of having to actually write the code to go and get all of that component and pull it back into your application, you can use the Vault agent as a proxy to actually do that heavy lifting for you. It will be able to leverage that template file and define what the output template should look like that your application can then read. And so here, our application has been given, it's got our server, it's got our user, it's given us our dynamic credentials, and now it's written that file dynamically with the new set of credentials to allow us to then get access to that file. So if our file then rotates or spends any time, that application would dynamically rotate that update automatically. And the way that, and because we're leveraging .NET, we can actually look at some of the files that we have around the project PS. Where is it? Program PS. No, that's not it. Yes, that one. So in here, there is the then onload refresh. So any file changes, i.e. when the agent updates that command, will mean that the app will automatically refresh and reload that. So your application will run seamlessly and update any of those application or new username and passwords that the Vault agent is pulling in for you automatically, and will refresh and onload the application. So using Vault agent in conjunction with your Vault, you can build into and code and leverage that code templatization for you so that you don't necessarily have to change a lot of your application code and just get Vault agent to actually do the heavy lifting for you. And so overall, again, that ease of adoption and a flexibility around being able to take Vault, use dynamic credentials to set your access to whatever those resources are. Again, limiting the amount of access and limiting your risk profile because those are dynamically changing, and trying to reduce your overall attack profile. And so with that, I will return back to Winston and hand it over to him to close it out.
Thanks for a great presentation and demo, Dave and Jane. Appreciate that. Now, I can see a couple of questions in the Q&A box. So if you gentlemen are ready, I'll fire them at you and let's see if we can get them answered. So the first one is, can Vault be used in on-premise environments, and can it be applied in Windows domain environments?
Short answer is yes. So that was an easy question. But to expand on that, so what I showed was HCP. HCP is obviously the SaaS offering, and that's a very easy, fast way to get going. We also offer, so part of that demo, the second part of that demo actually was run on premise effectively because it was run within my environment. So there are RPM installs for Linux, Windows, Mac OS, a whole bunch, any of the RPM package managers are supported. And so you can install that as a bare metal package into any on-premise component that you want to, and then build out and support a cluster. So the only guiding principle is that Vault is built around a clustered mechanism. Obviously, for a production security device, you want to have redundancy, and so we usually build around a 3 cluster tier as a minimum, but taking that 3, 5, 7, n+1 redundancy, and then that is available as just within the open source, so you can go and experiment that with the open source, and then as you move into production or into scalability, then there's DR and replication for true high availability that is available as part of the enterprise product.
Excellent. Thank you. Thank you. Okay. Second question, how does zero trust need to be adjusted for IPv6? Do the HashiCorp products support IPv6?
I would pass the first part to Jay to say what's your thoughts on the zero trust for IPv6?
Look, my thoughts are the thing with zero trust is not a product, right? You don't buy a zero trust. It's a strategy with a set of principles. And what that does is it gives freedom to align those controls that sit under those principles to to particular organizations to suit them. So my thoughts are that whilst the controls and the tools and that sit underneath that need to, like network segmentation or whatever it might be that we apply to actually achieve zero trust, those will need to evolve. The actual principles should still be able to remain. I mean, obviously security is a journey, as they say, and it may change and evolve over time. But essentially, we've got a strategy with a set of principles. I think those that they can still support IPv6 and other technologies as they come, but the controls and the specifics which sit underneath that will likely need to either be new or changed as that sort of evolves. Yeah,
and as from a product perspective, what I would say is that Vault is API based. So the products we Vault predominantly here is in terms of a service or a security tool. Vault is based around an API. So whatever you're doing, as long as you can make that API call leveraging IPv6, then, or your application could talk IPv6, then we don't really care because we're operating at that level. The GUI, you can use the GUI to get secrets, or you can use the command line to do it. And again, you're just using the transportation mechanism. The only real thing that needs to support IPv6 is obviously if you install it and setting up the cluster, which yes, they do. So I think to Jay's point, which is more important, is it's around, these are a set of tools that will allow you to move towards part of your strategy. So that, again, that 80% of the identity challenge we can help you solve, and that's part of that overall process.
Great. Thank you, gentlemen. One more. How is Vault licensed? Is it per user or nodes or per cluster?
So Vault is licensed on a per cluster, per client basis. So I spoke about the client, so our mechanism that tracks that authentication. So we do it on the number of clients and the number of clusters that are required.
Great, thank you. All righty, any more questions? Looks like that's it for now. Okay, folks, well, that brings us to the end of our session today. We hope you found it useful. As I mentioned earlier, this webinar was recorded. We will make it available on our website soon. We'll also send an email out to everyone who's registered with a link to the recording, so you can watch it again in your own time or share with your colleagues. If you like what you heard today and want to learn more about HashiCorp Vault and Azure, I encourage you to check out our Learn pages on our website, which you'll find at learn.hashicorp.com. Before you go, also I'd like to draw your attention to the QR code. So our hyper-specialized partner Servian that operates across Asia, Pacific and Japan is offering all attendees an invitation to join their follow-up hands-on workshop based on getting the most HashiCorp Vault. This session will cover why Vault, the extended security benefits, the developer benefits, how it scales across an enterprise, and what success looks like. They'll also include some demos, and I'll have an opportunity for more Q&A in that session as well. So please scan the QR code, register yourself for the next journey, or the next phase on this particular journey. And I thank you. Oh, hold on 1 second. Here we go. A couple more questions have just come in, Ben. So if you could just hold for a couple more minutes. Okay, so there's 4 questions here. What are the key factors of the zero trust model? What are the principles of zero trust security? What capabilities are required to implement zero trust security? And what is zero trust a model for? Is it more effective security? Number of questions there. Might be.
Yeah, I'm just wondering if we have another hour or so to cover. What I thought I'll do, there's a couple of things that I would say that. So we kind of talked a bit about the principles. We didn't really go into the pillars and the other pillars outside of identity and endpoints, which zero trust sort of covers. So there's a few. Microsoft have released a white paper and a maturity model. I'll paste a link in. I'll just find it now and paste it in, or we can send that out.
Okay.
But I recommend have a look at that white paper. It's got both a self-assessment that you can do. So you can run through a self-assessment on where you sit in like the maturity of zero trust, as well as an actual maturity model that you can evaluate against to sort of see, okay, we're here. This is where we want to get to, that sort of thing. And then to dive deeper into the other pillars, which we didn't talk about, there is a white paper, just a couple of pages, which is a good read as well. So I'll grab those links and share those with you.
Great, thank you, Jay. All right, well, there we go. Okay, well, thanks again for joining us today. Big thank you to our presenters, Dave and Jay, and enjoy the rest of your day, and we'll see you next time. Thank you, everyone.